All right. Good day, guys. I'm gonna just get right into it. So today we'll start by recapping what we did last week, and then after that, we will then look at the topics for today. Really. So I'm gonna start by recapping. Just bring So last week we spoke about this whole idea of algebra. We spoke about this whole idea of algebra and we introduced algebra. We introduced algebra and we said that algebra is basically a systemic use of variables. Can you hear me?
Yeah.
Hello? Okay. So we spoke about this idea of an algebra and we said that algebra is basically a systemic use of variables like your A, your X, your Y that represent some values. So these values at our level are really the real numbers. So we also touched on what real numbers are and what we can use them for. So this algebra and these values, we can use them to try and assign sort of variables that can have a proper definition and that we can use to calculate and solve real world problems. So the variable of interest could be, for example, interest rate. It could be speed that you travel, or time it will take you to move from somewhere to somewhere. So all of those are real world problems that we'll try to solve in mathematics. But all of those real world problems depend on some kind of a model. And we discuss the kind of models that we typically find. So typically you would find a situation like this. You'd find that you've got your data. Let's say you know the speed the person is traveling and you want to determine how quick they will get there. If we have speed is equals to distance over time or displacement over time. This is sort of our model. And then we have a model, in this case, which is speed equals to distance over time. Our data would have been given distance and time. And then we want to get to speed. So we typically have our data, all right? Then we've got our model, which is what tend to model. And the models in mathematics are really linear, which is really y equals to mx plus c, which I also touched on last week. And then there's, quadratic, which is y equals to ax squared plus bx plus c. Cubic, which is y is equals to a x cubed plus bx squared plus cx plus d. You have hyperbola, which is y is equals to a over x. So this is really defined by having the denominator as the variable of interest, the variable that we would have defined. That is what we have control over. And then we've got exponential. So which is y equals to ax. So all of these are the models that we'll typically be working with. These are the models we'll be typically working with, and we'll be given variables in terms of like x, and then we'll have to determine our output y. But that output will be driven by the model itself and what kind of a model that is. All right. So it could be number series, quadratic number series, or arithmetic number series, and all of those. So that's what we spoke about last week. We also spoke about this idea of real numbers and the kind of real numbers that we have. And we had to use a set. We had to define a set. A set is basically curly brackets like this, and is defined as a collection of objects. And each object, okay. Each object each object is called an element. Each object is called an element. So let's say we've got a set of objects. Let's see its letters A, B, C, D. We just have 4, right? So if we've got this kind of a set A, B, C, D, then A is an element of this set, B is an element of the set, D is an element of the set, and so on and so on. But the ones that we dealt with last week are the following: the natural numbers. And the rational numbers are natural, like the counting numbers, the numbers we use to count. And this would be 1, 2, 3, up until whatever. So the counting numbers 1, 2, 3, 4, 5, 6. Notice this does not include 0. As soon as it includes 0, then we have to define a new set of numbers, which is whole numbers. So once we start at 0 there, we're now talking with whole numbers. 0, 1, 2, 3. And notice it doesn't go to the negatives. Once we start going into negatives, then we've got integers, which will start anywhere, and then it would be -2, 1, 2. So these are our integers. Integers will start from the negatives, 0, to the positives. All right. And then we also defined rational numbers, and we said that rational numbers, is the set A over B, is the set A over B such that A and B are elements of integer. Remember what I said elements mean. I said that each number inside this thing is an element. Each number inside this thing is an element. Each number inside the set is an element. So we're saying that A and B are element of Z, which means A and B can be any number in here. And any number in here, we can start at literally -1,000, -99, 999, and so on, come up until 0, up until to the positives. The only condition that we require here is that B must not be equals to 0, because if B becomes 0, then we're dividing by 0, which is something we don't understand. We don't want to find ourselves in a situation where we have to take a number and divide it by 0, because we don't know what that means. And this line means such that, and then this E means an element of. All right. So this is really what we discussed last week. And then we also touched on the fact that any number that does not then meet this definition, so any number that cannot be written in the form A over B, such that A and B are integers, and where B is not equals to 0. Any number that is not part of that is called an irrational number. The examples of irrational numbers, we mentioned the likes of pi, which is, you'll see in a calculator, pi, which is a number like this. We use it when we find the area of a circle and all of those things. The number is 3,14159 going on. We've got things like square root of 2. The number is 141421. So even these numbers cannot be written in the form A over B. All right. They can be
you can write them in decimal numbers. And what you notice when you write them in decimal numbers is that the decimals don't seem to show any pattern whatsoever. All right, they're just random. The next number, you can't predict the next number by knowing the number before. Unlike other numbers like 1/2, which is 0.5. Okay, that one is a 0.5. But if you think about 1/9, which is 0.11111, you always know the next number is 1, no matter how many decimals you have. All right. So this is also called a fraction. This is also called a fraction. So what is a fraction? A fraction is a rational number written as a ratio, so as A over B, where A and B are integers. And this one is called a numerator. And then this one is called a denominator. So the one on top is called a numerator, the one at the bottom is called a denominator. All right. So that's the high level summary of what we've covered last week. Is it all clear? Do you guys have any questions?
Yeah.
Sorry?
We don't have questions. It's all clear. I don't know. Total language? No.
Okay, all clear for now. Okay, perfect. So now we want to start the lesson for today. So today we're going to look at operations with real numbers. All right. And I've just, to save time, pre-written this note. So real numbers is this thing that we've been talking about. Remember, it could be a number 2, it could be a number 3, it could be 1,000, it could be 1 million, whatever the number that could be a real number. We know what a real number is by now. And it includes natural numbers, it includes whole numbers, it includes integers, it includes rational numbers, and it includes irrational numbers. So whatever number you can think of, it's a rational number. It's a real number. And then now we want to know the properties of these real numbers. So we're going to start with the properties of real numbers when you are adding them, when you are operating in addition. We know that we've got 4 things. We've got 4 mathematical operations. The mathematical operations we have is plus, minus, multiply, divide. So these two are related. You can almost say they are cousins. So some of the laws, could apply both, but you must be careful because some of those laws, like the commutative property, this property, you can apply it on the negative ones, and I'll show you in a moment why. And then these two are also sort of related. There's some laws that could be applicable to both, but there's some that cannot be applicable to divide. So you ought to be careful with those. So the first property we have is additive identity property. So basically what this means is that when you have a real number, so say that real number is A, and that A could represent 5, could represent 10, could represent whatever. If you take that real number and then you add a 0, if you take that real number and then you add a 0, you can also write it this way. You can write it in the form 0, A plus 0, and you can write it as a form 0 plus A. Both of those will just give you A. So whether you start by adding the 0 or you add the 0 after you have your number, the answer is going to be A. And we call that additive identity property, that you can add 0 from the left or the right, it will always give you the same answer. All right. The second one we have is additive inverse property. The additive inverse property basically says that there are certain numbers, whether you start from when you add them, that would give you 0. It doesn't matter how you add them.
So for example, if you have a plus in bracket minus a, this number is going to give you 0. It's the same as if you started with minus a plus a. This number will still give you 0. All right. So when you've got numbers that are inverse, in a sense, of positive and negative, as I said, that these two are siblings. So when one is positive, the other one could be negative. When you have this inverse, which means the other one is the opposite of the other, they'll always add up to 0. So 2 minus 2 is 0. Minus 2 plus 2 is 0. So those are the kind of examples that we're dealing with. Associative property say that, when you've got, say, 3 numbers that you are adding, if the operation that you are using with those numbers is addition, then what that means, it means that whether you're adding A plus B first before you add C is the same as if you were to add A first and then you add B plus C separately. So whether you start adding these 2 first or these 2 first, it does not matter when it comes to addition. When we're dealing with adding, right? And then we've got a commutative property. This one basically speaks about, can you basically swap these things around? Can you swap them around? So A plus B is the same as B plus A. However, A minus B is not the same as B minus A. So addition has the commutative property that the order you call them, you can just swap them at any point in time. You can swap them at any point in time. You can write 2 plus 5, you can write it as 5 plus 2. If it's easier for you to add starting from the big number, for example. However, you ought to be careful with the differences, the negative sign. So A minus B is not the same as B minus A. You cannot just swap them. This negative is very important, and it really goes with this B. It really goes with this B. It must always go with this B. It must not change homes. All right. And then adding or subtracting fractions requires a common denominator, right? So assuming that C is not equal to 0, and I'm assuming this because I don't want to deal with a number divided by 0. So I'm just saying that is not, here I don't have that kind of a number. So I've got 2, 5, whatever the number is. If the denominator is the same, and I'm adding A over C plus B over C, then because the denominator is the same, it's a common denominator, I could easily just add the numerators. So I've got A plus B. The sign here is the same sign that I have in between, because this sign here must always go with the B. They are one family. Similarly, if I have A minus A over C minus B over C, I still have the common denominator, so I'm going to put the common denominator, and then the negative goes with the B. So I have A minus B. All right. Now, Tabile, if I have an extra letter, let's say I've got an extra real number D. So I'm introducing D, and then now I need to add A plus B, A over B plus C over D, where B and D are not equal to 0. So basically, if I've got a case where the denominators are not the same, how would I add it?
Gonna add A times D. I'm sorry, we're gonna say A times D
A times D
plus B. I'm sorry, plus B times C
times C
divided by BD.
divided by BD. Correct. Sorry.
No, nothing.
So basically, what you do, you multiply the denominators. You multiply the denominators, and then you cross multiply like this. You cross multiply like this. All right. Remembering that this belongs to this, so this must go with this. So if, for example, it was a minus. If, for example, it was a minus like this, A over B minus C over D, you still have BD. Now you've got AD minus BC. All right. So you must always be careful where your sign is. Also, if you had your negative here, then this was going to be negative. All right.
Yeah.
This negative sign can only go to 1. This negative sign here can only go to C or D. We always give it to C. We always give it to C because C is the sort of the number that is sort of on top that must take one of those signs. You can think of it as being negative, positive. If you do negative, negative, then it means this thing is now positive because the negative over negative will turn into positive. The same way positive, negative multiplied by negative is positive. All right. Yes. So basically, always remember the following. I'm going to write it here before I introduce this exercise that I want us to do quickly. So negative multiplied by negative is equals to positive. Negative divided. Okay, let me just do this. Negative divided by negative is also positive. And then we know opposite signs. Negative multiplied by positive is negative. Negative divided by by positive is negative. All right.
So now I've got some exercises for us that I want us to do quickly. I'm going to give you guys 2 minutes to think through them, and then you guys can give me what you think. Actually, not 2 minutes, just 1 minute. It's 56 now. When it says 58, we start.
All right. We are starting now. We'll start with A. So A, we're told that A is minus 10 minus 10 plus minus 5. And then someone must tell me what to write and what is the answer to this question. What is the first step that you would do?
We'll multiply that
How?
negative. multiply negative, that negative there in between -10 and -10 in the bracket.
This
Oh,
one.
yeah, to make the other one positive.
Mhm.
And then that way it will become effective in less pro part. Then it becomes 0, and then the only thing we left with is -5.
Perfect.
Yeah.
Perfect. B.
B, I need some time, but I see a pattern though.
What is the pattern?
I don't know. Yeah.
Let's look at the common factor. So the biggest number we have here is 49. 45, sorry. 45. So if I put 45 here, how many times does 9 go into 45?
5 times.
5 times.
Yeah.
Okay, so I must multiply this 9 by 5. So I'm going to do it here so that you can see. So I multiply by 5, I multiply by 5. I've essentially multiplied by 1 because 5 divided by 5 is 5. And anything multiplied by 1 is that thing. So I've not changed my equation. I still have the same equation. Similarly, here we multiply by the 1545.
3/3.
3/3. Similarly, I've not changed the value of that number. I've just multiplied by 1. Anything multiplied by 1 is that thing. Now I have the same denominator of 45. Here I've got 2 times 5, which is 10, minus 3 plus 8. And what is the answer to this?
15/45.
And what is 15/45?
1/3.
Yes, because 43 times 15 is 45. Correct. So,
Okay.
so when it comes to mathematics, you also need to be able to read statements and understand what they mean. All right. So, for example, this question C says that what is 8 subtracted from the sum of 3 and 1/2? Thokozile, what should I write? What does the statement mean in a mathematical equation?
There is having some technical issue. Sorry, please repeat the question.
What is 8 subtracted from the sum of 3 and 1/2?
Oh, okay. So they're basically saying 8 minus the sum of 3 and 2, meaning like 3, 3 and 1/2. So basically they're saying 3 plus 1/2.
So is that what should I write? You tell me what I must write.
So it's gonna be 8 minus 3 plus 1/2.
Like this.
Yeah.
Tavile, what do you think?
What is 8? Given the sum of. Yeah, that's about it. You can put 3 plus 1/2 in brackets for more clarity.
Okay. So how would you define this in words? Would you say this is 8 subtracted from the sum of 3 and 1/2?
Actually, no. It's the other way around. Because they're saying 8 is subtracted from the sum of that. So mabaqeda ukuhlanganisa 8 plus 1/2, they subtracted 8. It's the other way around.
Uhlanganisa Clara because you must subtract from 8 subtracted from 3 plus 1/2. That's how you will write it. And then now, what is the answer of this thing?
Should we do it with you or tell you the answer?
Sorry?
Okay. Do
So
it.
this becomes 2, right? And then I multiply by, correct?
Yeah.
And then I'm going to subtract the 8.
Yes.
So I only have 7 over 2 minus 8, but the 8 I can write it as 16 over 2. Do you guys agree?
Yes.
And then I have, what is 7 minus 16?
Negative 11.
11.
I'm sorry, 9.
9 over 2. All right. Okay. So now we're going to speak about the properties of multiplication. So we've spoken about the properties of addition and the properties of division. So we've spoken about the properties of addition and subtraction because they work, almost together. Now we're going to speak about multiplication. And similarly, when we have real number A, B, and C, we have the following properties. The zero factor property means that anything multiplied by 0 is 0, right?
Right.
So I have, and the order does not matter, whether I multiply 0 first, and then I multiply A multiplied by 0, or I say 0 multiplied by A, it doesn't matter because the answer there is 0. Anything multiplied by 0 is 0. Even if that thing looks like this, 1 over A multiplied by 0 is 0, because we're saying anything. So any real number, any function of a real number. And remember, 1 over something is also a real number because we spoke and we agreed that fractions are also real numbers, like your A over B that we spoke about, right? And then we've got multiplicative identity. Now, the identity here speaks to 1, and anything multiplied by 1 is itself. So A multiplied by 1 is equals to 1 multiplied by A, and is still equals to A. So anything multiplied by 1, and it doesn't matter whether you multiply by 1 first or you multiply you multiply the A first. However, if this was A divided by 1, it cannot be 1 divided by A. These two things are not the same. This is A, this is 1 over A. This is 1. So if it was divided, it makes it completely different. They are no longer the same thing. So this part of multiplying by 1 only applies in multiplication. It doesn't mean that you can't multiply this. So 1 over A multiplied by 1 is the same as 1 multiplied by 1 over A. This is correct. However, this, it's not the same thing. All right. So now, the next property is associative property. So when it comes to multiplication, similarly with plus, because multiplication grows, it's like addition, it makes something bigger, all right? So when you're multiplying A multiplied by B multiplied by C, whether you start by multiplying A and B first, or you start by multiplying B and C first, or you start by multiplying A and C first, it doesn't matter. With multiplicative, you can do that. With divide, you must be careful where the divide is at, right? Then we've got cumulative properties. Similarly, 2 multiplied by 3 is the same as 3 multiplied by 2, and it's all equals to 6. So the order of multiplication does not necessarily matter. It doesn't matter at all. However, if it's divide, right? And I say 4 divided by 2 is not equals to 2 divided by 4. Right. However, 4 multiplied by 2 is equals to 4 multiplied, is equals to 2 multiplied by 4. So if it's multiply, you can change the order, but if it's divide, you have to be very careful. Those two things are not the same. All right.
Yeah.
So things you must always be careful of: subtraction and division. You must always be careful when you deal with those things. Think very deeply when you are faced with those. All right.
Mhm.
Here comes another exercise. Now, the exercise requires you to multiply the following numbers. So how would you multiply A, which is 5 minus 3 minus 2 minus 4? How would you multiply this? What is the answer to this thing?
Negative 120.
Sorry?
It's negative 120. I started with the -3 and -2, and I got +6. And then I multiplied 6 with -4. And then I multiplied with the answer of 6 times 4, which is -24, with 5. That's impossible. It got negative 120.
Okay. Do you understand it, Pumela?
Yes.
Now you tell me how you do B.
Okay, so so first thing you need to do is divide.
The first thing we need to do is divide, correct? So what are we dividing?
So you're gonna divide 10 by -2, which is gonna be -5.
-5, and then?
And then you're still left with the bracket. With the open bracket -5 close bracket. And then you multiply the two, which will give you +25.
Correct. So every time there's a divide, you must always know that the divide, like the minus. Remember in the minus, I said that the negative will stay with the B here, for example, and it will always stay with the B here. Divide is like that. You can't borrow with divide. You can borrow with multiply, but divide stays with the number that is attached to it. And in this case, essentially, the divide ends here.
If I was to rewrite this, I could rewrite it like this, like this. Correct?
Correct.
So one of the mistakes that you could do,
And that many students do, is to assume that all of this, so basically assuming that this is like this. This is incorrect because there's no double brackets here. If only there was 2 brackets like this, we could write it like that. Correct?
Yes.
and then now C.
C. C is -4/5, 25/12. What is the answer to C? And how would you think about it?
You can multiply straight out because it's not like there's a plus or a multiply or a divide sign where you have to flip it. It just you can be like -4 times 25
Which is?
-100.
Mm-hmm.
And then 5 times 12, which is 60.
Okay, and what is this? 100 divided by 60, what is it? What is the common factor that you can take out?
You can divide it by I don't know, 20.
Yes, you can divide both sides by 20. And then you're going to get?
And then you're gonna get negative a 5 and then 3 over 3.
Alternatively, you must always try and avoid multiplying big numbers. So you must see where there's opportunities for you to remove some numbers or to make them smaller. So by that, what I mean is that the 25 and the 5 are factors, and 25 divided by 5, you get 5, because 5 times 5 is 25. Here, with 1, then we'll have 25. 4 and 12 are factors. 4 over 12, 4 gets in here 3 times. Then here I'm left with 1. Therefore, I've got minus 5 over 3. By just recognizing where the factors are and thinking through which ones can cancel each other. Right? Perfect. And then the other section that we will be looking at is basically this thing called reciprocals. What are reciprocals? Reciprocals are numbers that when you multiply them, you get 1. So 2 multiplied by 1 over 2, it's 1. Therefore, 2 and 1 over 2 are reciprocals. Similarly, A over B and B over A are reciprocals. And that's because if you take A over B multiplied by B over A, you get A over B divided by A over B, which is equals to 1. These are reciprocals. Why are they important? They're important because they help us know how to deal with these guys. So you guys have told me how to deal with it when it's plus and minus. Tabile gave me the equation to use, which we focused on when we were doing this here. We said this is how we can do it. But when there's now a divide sign, you do this thing that so the first thing you want to do, you want to make the denominator 1. So what I do is I multiply by the reciprocal of this denominator, but I repeat it twice so that it's 1. So I would say, well, my denominator in this case, what I'm dividing by is C over D. So I want the reciprocal. Reciprocal is the opposite. So it's D over C. I multiply by D over C divided by D over C. Now, because this D over C and D over C is similar, it's D over C, D over C, it's still going to be 1, because any real number divided by itself, it's 1. So this real number in this case is D over C. Remember, we said that rational numbers are any number that can be written as A over B, such that A and B are integers, where B is not equal to 0. As long as C is not equal to 0 here, this whole thing still gives us 1. So I'm multiplying by 1. I'm not changing my original equation. I'm still where I started off. So we multiply by this. Then when we multiply by this now becomes essentially, these are reciprocals, and then they make up 1. And then I'm left with A over B multiplied by D over C, which is A over D multiplied by D over C. So you'd often hear that if there's a divide, you can change the divide into multiply and then flip these 2. You guys have heard that, right? This is where it comes from. You first initially divide by the reciprocal of the denominator, and then you work it out, and then it's going to lead you here. This is the mathematics of it. Anyways, in general, this is what you have. You have A divided by B divided by C over D.
is equals to A divided by D multiplied by D over C. So the reciprocal of the number that you were dividing with.
And then you get A multiplied by D over B multiplied by C. Correct?
Correct, yeah.
So now we've got another exercise that I want us to do. It's just 3 questions, not a lot of questions. So now we have A 5 over 4 divided by 3 over 5 multiplied by 1 over 2. Again, we start with the divide.
Right? Remember,
BODMAS, which we'll touch on a little bit more when we get back. BODMAS say that, hey, start with a bracket of division. So if you have a problem, you start with divide, you go to multiply, you go to addition, you go to subtraction. So that's the order of operations that you must use. So in this case, we're going to start with the divide. And what can we do with the divide? And it's something that we've just learned.
Oh, we can change it to multiply by switching 3 over 5 to 5 over 3.
All right. Now we have all multiply, multiply, multiply. What is now our answer?
So, you can say 5 times 5, which is 25,
Yes.
over 4 times 3, which is 12, times 1 over 2,
Which is?
25 over 24.
Correct. B, 1 over 2, 3 over 4, divided by 1 over 8. What do we do here?
Okay, so basically you're gonna start by saying 1 over 2 times times 3 over 4 times 8 over 1.
Correct. What is the answer here?
And then you can say 1 times 3 times 8.
Which is equals to what?
24.
24 divided by?
8.
Which is equals to what?
Which is equals to, you can divide it by 3. Wait, can you? No, we can't divide it by 3. 2. Okay, can I simplify it first? If you divide it by 8, it's 3, which is, yeah. I wanted to divide it by 4.
What you must be able to recognize is what is the product of these two.
Mhm.
2 times 4 is 8. Then 8 cancels. Then we're left with 3 times 1 over 1, which is 3.
Oh,
Just be careful of ways to simplify because you don't want these numbers to be too big. Now you don't know what is 24 over 8. All right.
mhm.
The next exercise is 2 minus 4 over 5 minus 2 over 15. What do we do?
Okay, so first thing, what is this? BODMAS says, BODMAS brackets, right? So you're gonna say 2 minus, then open your bracket, and say 4 times 15.
4 times 15. Okay. So that's correct to say 4 times 15. But we must always look for simplifications. Right? So you always come, the first thing you do, you look at your denominators. What can I do about this to make them the same? I've got 5, I've got 15. What is the relationship there? 15 is 5 times 3. So what I can do is to multiply here multiply by 3, multiply by 3, 3 over 3. I've multiplied by 1. I've not changed anything. And the reason I'm doing that is because I want this denominator to be 15. And then this is going to be 12. So as in actual essence, I've got 12 minus 2 over 15 over 15. Right? And then we have 2 minus, what is this now?
10 over 15.
And then now, what is the answer to this?
Okay, let me try if it's simplified. I really don't know. Let's say 30
Yeah.
minus 3.
80 minus?
Minus 2. Wait, 30 minus 10. Sorry.
80 minus 10.
Divide by 15.
Mm-hmm.
Which is 20 divided by 15.
Which is equals to?
Divide by 5 up and down. So you can say times denominator 5 over 5.
5 over?
You can say it's multiply 20 divided by 15. You can say multiply by 5 over 5, which is 1.
Divide by 5 over 5. We have to make it. And then you get?
4 over 5.
No, 4, 3.
Yeah.
Remember, 20 can be written as 5 times 4, whereas 15 can be written as 5 times 3. Then the 5 cancels out, we're left with 4 over 3. Alternatively, you can here say you've got 2 minus, recognize already that 10 and 15 is 5 times 2. So is the same as 2 over 3. 10 over 15 is the same as 2 over 3. Yeah?
No, it's fine. It's okay.
And then you've got 3. You've got 6 minus 2, which is 4 over 3. Correct?
Correct.
Okay, last section, as we are running out of time, is exponential notation. Exponential notation is this thing called exponents, where you've got a number and some power, or a base and an exponent. So for example, if you had 4 times 4 times 4 times 4 times 4, 5 times, that could be represented as 4 exponent 5. In this case, the 5 is an exponent, the 4 is a base, right? And then next week, we'll delve deep into the exponents, but I'm just introducing the exponents now. So the base is a factor that needs to be multiplied a number of times. So you notice nowhere in my original equation do I have 5. Nowhere do I have 5. Only the number of this force. So the 5 represents how many times is this 4 repeating itself. It's not a part of my calculation, all right? So it says to me, I must multiply this 4 5 times, multiply this 4 5 times. So this exponent represents or indicates the number of times the base is repeated as a factor. What is a factor? Something that you multiply. So the base 4 is a factor. 5 tells us how many times must this factor be multiplied. In this case, it's 5 times. In general, if A is the base, that is represented as a factor 9 times, then A exponent 9 is the same as A times A times A times A 9 times. 9 factors of A. Oh, sorry, why am I saying 9? N times. If N is 1, then you multiply it 1. If N is 10, you multiply it 10 times. If N is 20, you multiply it 20 times. If N is 100, you multiply it 100 times. All right. And then we've got what we call squares. Squares is basically A to the power 2. This is a square. When you multiply 2, you will say A squared. And then we've got cube. Cube is when you multiply 3 times. And we say A cubed.
All right.
All right.
Yes. And then I'm going to do this exercises very quickly. What is -1/3 all to the power 3 or exponent 3? How do you deal with this?
Maybe I really don't. I know. I know. Okay, so I cannot please do. I'm so sorry.
Yeah.
So we can say -3
-3
and then to the power of -1
to the power.
of -1.
Mhm.
And then from then obviously the bracket cube. The bracket.
Mhm.
The cube. The 3.
Okay.
And then you can say after that you can say -3 to the power of minus 3 like cubed.
Okay.
And then after that you can say after that you can say 1/27. Don't
Where's
forget
the
the minus, because okay, let me do it simpler. Yeah, but this gets me, yeah, that's what I was trying to say. And then it goes to -1/27.
correct?
Mm.
And then what about this one?
And you can do the same thing also.
So I
Is
can
it?
write
Yeah, 4 and
in
then 12.
a what
Negative
where
equals to -3 minus -4.
is going to be.
-3 to the power of -4.
Now you ought to be very careful about this negative, this negative, this negative, this negative. This negative is also multiplied. It's part of the bracket. So here, why we can maintain the negative, we don't maintain it because we like it. We maintain it because we must multiply it 3 times. So we say negative multiplied by negative multiplied by negative, we get positive multiplied by negative, which is negative. That's why we maintain the negative here. As soon as we open brackets, we do the same here. We must say negative multiplied by negative multiplied by negative multiplied by negative 4 times, and then we get positive.
Yeah.
So now this one must no longer be just negative, it must be positive. So when the exponent is even, your solution is always going to be positive. When your exponent is odd, then you must look at the sign. The sign sort of remains the same. All right.
Oh,
And then
yes.
what is this +3 exponent -4?
Is 1/3 to the power of 4.
It's 1/3 to the exponent 4, which is equals to
1/81.
1/81. Then what about -2 to exponent 4?
What is it? 16.
Why
Wait,
positive?
first.
Why positive?
Because the exponent is an even number.
Remember, the exponent is with 2, is not with the negative. So when the exponent is with when the exponent is with the negative, they will write it like this. We must have brackets. But when there's no brackets, the exponent with the number, not the negative. The negative is just negative. It's not multiplied any times. It's just there once.
Alrighty.
And then it becomes -16. All right. And then what is the answer to this one?
16.
+16. Here,
Here you can then multiply because it's all in the bracket. So if I was to write this, I will write it like this. -2 multiply -2 multiplied by -2 multiplied by -2. Then I'm going to get positive 16. But this one, I have to write it like this: -2, 2, 2, 2, because the 2 is the one that repeats 4 times. Correct?
All right.
That's where our lesson for today ends. Are there any questions or clarifications?
No, I'm good.
No, all good. Okay. All right. I will, yeah, okay, no, it's fine. I'll give you some exercise at some point. So this is where our lesson ends for today. Thank you very much for joining. All right, bye-bye.